Let me try to bring kind of historical perspective on the usefulness of data. This is from the States. Before the end of 20th century, the US Department of Commerce named the development of the national income products as its achievement of the century. And Paul Samuelson went even more than this and considered this as much broader achievement. The GDP and the rest of the national income accounts are truly among the great inventions of the 20th century. So the great invention of the current century might be the data revolution we have had over the past decade. In particular, the big data concept has emerged as an important topic in the fields of data creation, storage, retrieval, and analysis. Big data is not a single technology, technique, or initiative. Rather, it's a trend across many areas of business and technology. Corporates especially are defining new initiatives and reevaluating existing strategies to examine how they can transform their businesses using big data and discover potentially valuable business insights and trends. The most central banks, on the other hand, are trying to catch up with this rapidly changing world. In January 2015, the BIS Irving Fisher Committee on Central Bank Statistics launched an online survey on central banks' use and interest in big data with collaboration of the Bank of International Settlements, the BIS, the Central Bank of Turkey, and the European Central Bank, the ECB. The survey answered by 69 IFC member central banks and monetary authorities worldwide, representing a response rate of 83%. Let me try to summarize the main conclusion of this survey. The first conclusion is there is a strong interest in big data in the central banking community, in particular at the senior policy level. But central bank actual involvement in the use of big data currently quite limited. Big data can be useful for conducting central bank policies. And the fourth conclusion, big data are perceived as potentially effective tool in supporting macroeconomic and financial stability analysis. The next conclusion is big data may also create new information needs or research needs. International cooperation can add value. Exploring big data is complex, multifaceted task. And the final conclusion, regular production of big data-based information will take time, and especially because of resource issues. On our session today, we have two presentations, mainly referring to big data and web-based information, and the discussions will add an additional angle, the microdata hub perspective. Without further ado, let me introduce our first speaker of the session, Alberto Cavallo from MIT. Alberto is the Associate Professor of Applied Economics at MIT and a Faculty Research Fellow at the National Bureau of Economic Research. His research focused on the micro-level behavior of prices and its implication for macroeconomic theory and policies. His empirical work is based on the use of daily data collected from hundreds of online retailers around the world, and he co-founded Billion Prize Project at MIT, an academic initiative that pioneered the use of the online data to conduct economic research. And the Prize Stats is the leading provider of the high-frequency inflation statistics, which I looked quite a lot, especially to check the actual inflation rate of Argentina. So I see there is a difference between the official inflation rate and the inflation rate you calculate from your model. And finally, Alberto received his university degree in Argentina in 2000, and MBA from MIT in 2005, and PhD in economics from Harvard University 2010.
No, that's right. It was pointed out that Argentina didn't win at rugby. We didn't win at soccer as well, but I don't want to remember that, particularly here being in Germany, right? But thank you very much. Thank you for that kind introduction. Thank you for the invitation to participate. I'm going to do similar to what Julia did, tell you a little bit about what I'm going to do and then repeat it at the end. But I want to make this point clear. I'm a macroeconomist that works a lot with microeconomic data. And the truth is, particular price data. And the truth is, I think in macroeconomics, in research in particular, has seen the introduction of new data sets in the last few years that have provided us with an amount of information that has allowed us to improve and test our models in ways we couldn't do before. In particular, there were three. We had access to raw microdata from statistical agencies that was traditionally used to construct CPIs or PPIs. We also had access to scanner data, which is the information that is recorded by companies like Nielsen. When you go to a supermarket, it passes through a scanner, all that gets recorded, and we get a lot of details on transactions. And finally, something in recent years, which I work on, is the possibility to use the web to collect information that is dispersed across many sources. And in terms of the uses for macro and international economics, we can use it first to improve the way we measure some economic indicators. And I would divide that between trying to use alternative data sources to measure the same things we were measuring before. I'm going to show you an example with inflation. Or we can use it to build new types of indicators as well, and some people are working on that area. And then we can use it for research, as was mentioned in the first discussion. Economists have a lot of models, and usually we have relatively little data or limited data sets for which to test our models. And the work we do at the Billion Prices Project specifically tries to do a lot of this type of work, see how the data helps us improve the way we model our economies. And I'll discuss briefly two cases. One has to do with the way we model price stickiness, which is an essential element for monetary policy. To understand what are the real effects of monetary policy, we need to understand what drives the adjustment of prices, what makes prices adjust faster or slower. And second, particularly for the IMF, this is very important. Usually when we discuss about the value of currencies or whether currencies are over or undervalued, economists have these very simple theories like PPP, and the data we have to test this type of theory is usually limited and not well suited to what we do. So I'm going to go through this, but first let me clarify something. Although I work mostly with online data, I think it's important always to understand what are the advantages and disadvantages of each of these data sources. They all have them. And also, why were they collected in the first place, which is part of the problems we face now with big data, is that usually there are these massive data sets out there that were collected for completely different purposes to what a researcher or a statistician needs to compute a particular statistic. And we often have to deal with the problem of coming up with ways of solving for potential biases that the sampling mechanism had. My view on this point is different. I don't see this big data opportunity as an opportunity to kind of collect all these data sources that have been put together for other purposes, but rather I think of it as a data collection tool and a data collection technology that allows us to design where we want to go and what we want to collect. But I went a little off topic there. Let me talk about CPI data. It's a type of price data we know a lot about. The greatest advantage is that it's a very representative sample of goods. We have very long time series, and we typically get information from transaction prices. The drawback, which was also discussed in the past, for example, has to do with the big cost to collect this data, the lags in the delays we have to provide this information to policymakers. And since it's actually so costly to collect this information, we're typically reduced to relatively small data sets or relatively few models of goods when we do the sampling. And in particular, it's also very hard to make international comparisons because we have different entities collecting the information in different countries. Now, one of the first innovations in terms of price data was scanner data, and it had clear advantages. It had a lot of granularity when it first appeared. It was transactional data, so when something was sold, it was recorded in these data sets, and it was higher frequency. So people got excited about the prospects that this had. But on the other hand, it's a very high cost to collect. There are limited coverages because it's typically available only in supermarkets or department stores. And since these are different organizations collecting the data, the characteristics are also very hard to homogenize, and in particular, making international transactions is tremendously difficult. Now, the third kind of data is the one I work with. And here I'm illustrating how it can be collected. I want to be clear exactly on what we do. Any page that you visit online, essentially I'm showing you here an example with the Apple Store, has this graphical representation. But behind it is a very structured computer code called the HTML code that you can see there in this particular example. And what the code does is it allows the browser to interpret the information and render it graphically. And it looks a little bit messy, but when you actually look at the particular information, you can see that there are these tags that are pretty constant. They're called HTML tags. And you can teach a software to identify those and collect the information that's in between, which would be, for example, the red data that I have there, which has the ID of the product, the product description, and the price. No? And it's a lot of work initially to set up these robots, but after that, you can set it to run automatically. It downloads the page, it stores the information in the database, and the next day, it runs again. And you can do this for hundreds of retailers like we do at the Billion Prices project. And over time, you are collecting these massive data sets for essentially everything that these retailers sell. And you can capture anything that's on display on that website. So naturally, the data sets are extremely large. The frequency is very high. We can do this at whatever frequency we want, but we do it on a daily basis. It is relatively much cheaper to collect. We have information for all products and a lot of details about the products. And very importantly, I think for inflation measurement, for example, one of the areas where this can help a lot is the fact that as soon as a good is being sold, it enters into our sample. So we sample it immediately. And if you're going to make international comparisons, for example, you can apply exactly the same data collection methodology and the same type of adjustments if you want, no matter where you're collecting this data, because this is all done remotely. But it also has disadvantages. We have fewer retailers and locations and CPI. We have relatively short time series because we cannot go back in history. Only since we started collecting data back in 2008, we have information. Not all categories of goods and services are available online, at least not yet. In particular, services are not available. And also, there's the question whether online and offline prices may behave differently, which we've done recently a lot of research on. Now, what do we do? At the Billion Prices project, we essentially have this academic initiative that pioneered the use of this type of online data, and we experimented with the first topic over there, which is the inflation measurement and forecasting, and also some research applications like I described before. Let me go into the case of inflation measurement. The idea here was to see if we could use this alternative source of information and traditional CPI techniques to produce alternative statistics. We started, as was mentioned, we started in Argentina. I'll show you some results there in a second, because that's where I'm from, and in Argentina started having some questionable statistics. So we needed an alternative data source. But then we realized that it had potential all over the world, and we started expanding our data collection in the US. In 2010, we produced an inflation index in the US, and since 2011, there's a company we started called Price that has been publishing daily inflation indices in 22 countries in near real time, with only a 3-day lag, using essentially the same methodology everywhere. The results are different across countries. What I'm showing you here is probably a very extreme example, the case of Argentina. What you see on the top graph is actually the price index. I know you cannot see probably the numbers very well of the bottom graphs, but we have the annual inflation rate on the right and the monthly inflation rate over time since 2007. No? And what these graphs clearly tell you is, well, the top one clearly tells you there's a big change in the difference in the trend between the official index and the one we were collecting online. That's pretty clear. The annual inflation rate, however, you can see that there's a big difference in the level of inflation. The official indices, the index used to say that inflation was around 10% when our numbers were 30%. And you can see that they move closely together, no? Which suggests that the algorithm to lie about the inflation index wasn't very sophisticated. In fact, if you take the real inflation rate and you divide it by 3, you get a very good approximation to the CPI in Argentina, I have to say. But it also says that this co-movement gave us the clue that we were capturing with the online data something important about the way the economy was behaving. And we could use this even in countries that weren't particularly doing anything to their statistics, that weren't lying about their statistics. So we replicated the same methodology in other countries. What I'm going to show you now is the US daily index that we have been producing and releasing live since 2011. The blue line is the daily index, and the red line is the CPI. Now, when you look at this index, obviously the differences with the CPI are much shorter. There are still many reasons to expect these things to deviate over short periods of time, but overall, they co-move together very closely. The online index in particular is very good at detecting these changes in the inflation trend, which I've marked on this graph. For example, the first one you have there is September 15, 2008. For those of you who remember the crisis, that was the day Lehman Brothers went bankrupt. So obviously, many of these very large retailers we follow online were anticipating the fact that a recession was coming, and they were very quickly reducing their prices, and we were capturing that with a very real-time or live metric of the economy. So the index is particularly good at detecting those turning points. And you have the annual inflation rate and the monthly inflation rate in the case of the US. And we actually do this in 22 countries, as I was saying. Some of the things we find are things that have to do a lot with whether the online market is integrated with the offline market or not. What you're seeing there is that typically in developing countries, we have less of a closer match with the CPI, and in developed countries, actually the matching is much stronger because naturally the online sector is more developed. We can produce sectoral series and aggregates as well, with essentially, as I mentioned before, the same methodology everywhere. So we think there are a lot of advantages to be mindful of. Obviously, speed is one of them, but there are also interesting differences, and understanding what those differences are, I think can help us even improve the way we measure inflation in the future. One of those differences has to do, for example, with quality adjustments. One of the things we don't do is any hedonics that are traditionally done in CPIs, and we were puzzled by the fact that by constructing these simple indices, we were able still to approximate the inflation estimates produced by statistical agencies with the hedonics that they were using. And one of the things we realized is that this is, for example, where online data has one of these big data advantages. And there were some results theoretical that had been done, for example, by Mick Silver, empirical as well, Mike Silver or Carol Corrado on the use of scanner data to show that if you had data that inherently has a lot of goods and complete price spells, you can generate an approximation to the true rate of inflation, which is very similar to the one you would obtain with the hedonic technique. And the logic for the intuition is actually in these two graphs. I'm showing you what a traditional CPI data looks like. Since it's so costly to collect, what you're seeing there, for example, is a hypothetical example of going and collecting the price of a TV. Since it's costly to collect, you typically would collect the price of one TV, follow it over its life cycle. Right before it disappeared, they would have this massive sale, and then when it disappears from the store, the person doing the data collection has to switch to a different model. When they do that switch, there's a price change, and they have to decide how much of that is a quality change versus an actual price change. Now, we have to do all the hedonics typically because of the limitations of the traditional data, in the sense that it was a censored spell and relatively few goods. Now, when you think of the type of data you can collect online, it's actually complete price spells and a large number of overlapping price series. No? And what happens intuitively is that at any point in time, those goods that are about to disappear numerically are relatively few compared to all the models of TVs that are being sold out there. So they don't matter as much and don't create that type of volatility. This is an area that requires a lot more research, but it's one intuitive way we can see an advantage of big data or a simplification of these big data qualities of online data. Let me skip this. The other thing that online data has is it has a significant anticipation that goes beyond the fact that we can get to the information sooner. What we find is that often some of these large retailers, when they get a shock, they do the price change online first, and later they do it offline. So that usually gives us an anticipation about 2 to 3 months, depending on the country we are considering. This is shown here graphically with a simple impulse response function that shows you how long it takes for a shock in our index to appear on the CPI. And you can see that on the first month, there's already some impact, but the peak of the impact is actually on month 3 and 4, when we see the full pass-through from our shock, the shocks we see in our index to the CPI. And we believe this has to do with the fact that online prices have a behavior that is different, and they tend to react sooner. And economists have a lot of theories of why that could be: lower menu costs, lower customer anger at price changes, and different reasons. But statistically, you can measure this very clearly and use it in any forecasting model that you want to apply in this case. No? Just briefly, many people also often question whether online prices are similar to offline prices. It's something we have tried to, through our research, analyze as well. On one hand, very few transactions take place online. Today, even in the US, only 7% of transactions are online. So most of what we would want to capture is not on a transaction that takes place online. We view essentially the web as a tool to collect those prices that we could also collect by physically walking to the store. We have tested this extensively. One of the ways to say that online and offline prices are similar is to show the price indices, but we're doing it even more explicit by running experiments where we send people to the stores with mobile phone and we tell them, scan randomly some items. That sends us the price in the physical store, and we immediately check it online as well. And we typically find that around 70 to 80% of prices are identical in a sample of 10 countries and over 50 of the largest retailers in those countries. So there seems to be a lot of similarities. And while the web hasn't been the equalizer of prices across retailers, for single retailers, it seems to have provided an incentive for them to price exactly on the web, offline, and in many of the stores that they have across locations. So that's one of the implications of this type of research. Now, research applications. And I don't know how I'm doing in time. Okay, so I'll make this relatively quick. This first point is about the price stickiness. Since some of these micro data sets became available, many people were using them to produce statistics and try to guide our models. There were many puzzling findings at the beginning when people used, in particular, scanner data or CPI data. One of those puzzling findings was, for example, that there were a lot of small and tiny price changes, which economists thought was surprising. Our basic models, micro-founded models of price changes are menu cost models. There's an adjustment cost to make a price change, so why would a retailer decide to make a 0.5% price change, for example? And then a lot of people were coming up with theories to try to account for this. what we showed is that it had a lot to do with the way scanner data and CPI data was being sampled, and that wasn't being accounted for. To make things simple, in scanner data you have weekly average prices, so that tends to make a large price change actually appear like two smaller changes, and can completely distort the way the distribution of the size of price changes looks like. So it's when we presented this research, it's an example of how being able to collect data that is specifically targeted to the need in whatever you're trying to test can help tremendously in interpreting the results. And this wiped away many of these spurious small changes that were completely altering the shape of the distribution. Now, online data has the capacity then to not only measure inflation, but also measure stickiness in real time. So it's something that is still very early on, but for central bankers who want to understand if the prices are likely to change or not, and which sectors are going to react faster, we can have live metrics or that, and not metrics generated with tremendous lags that may not be informative at all about the current situation. And then finally, let me just say, I'm working a lot these days on international relative prices, what I was talking about at the beginning on PPP. If you think about it, the ability to collect data online in many countries also allows us to create these large baskets of goods that we can price everywhere, essentially like a Big Mac index, but instead of relying on a single good, we could do it for thousands of goods and generate PPP statistics. It can tell us something about the value of the nominal exchange rate and the real exchange rate, whether it has deviated too much from what is traditionally seen or historically seen in the data. And we have several papers on that. One that was published last year specifically looked at global retailers and tested the law of one price. And we found that the law of one price almost never holds except within currency unions. And we use the US and some countries that are dollarized to show that often these retailers, whenever they have to show prices in exactly the same currency, it seems to impose some constraint on them that they have to make prices identical for consumers, likely because consumers don't understand why the exact same good may be sold for the same, when it's displayed on the same currency, for different prices in different countries. Although there may be perfectly logical economic explanations to set a different price in Finland than in Spain, customers may have a hard time understanding or accepting that, and therefore retailers have an adjustment to make, and they make prices identical. And this has implications, obviously, for the dispersion of price changes. The euro was created, one of the goals was, or expectations was that prices were gonna merge. Now we are expanding this much more and going beyond these global retailers, and then linking goods in these large baskets manually. This is a more complicated thing where we cannot use automated techniques so much. Although you can use machine learning, for example, it's something that's used in these big data applications. You can teach a software to identify goods. And what we're doing here is essentially we go to Germany, we look for all versions of milk, and we link them into a category we call lactose-free milk, for example. It's very specific. And we get the price in several other countries. And with that, we can build these real exchange rates, or if you want, the ratio of prices times the exchange rate, and see how they co-move together. If you do this with CPIs, you essentially get that there's a nominal exchange rate shock, and prices don't adjust. So the real exchange rate, the relative cost of the basket, adjusts just as the nominal one. When you do it with this type of data, what you get is that prices do adjust. And it's specifically because we're comparing exactly the same good or the same baskets across countries, and this is driving, I think, many interesting applications that have to do with the value of currencies and where they will be headed in the medium term. So let me just conclude. I think online data can be a reliable source of inflation measurement or data for inflation measurement. It also dramatically increases the availability of data for people doing academic research. Let me just finish with a quote by Zbig Rilges, a famous econometrician who wrote about the uneasy alliance that economists tend to have with data. And he pointed out the fact that we don't want to get involved in these grubby details, he put it, of actually collecting the data sets, and we tend to find this data or accept it from statistical agencies and complain about it. But I think that is changing dramatically. He wrote this many years ago when some fields in economics were starting to run experiments and collect a lot of survey data. Macro and international haven't done so much along that dimension, but all these tools of data collection are changing the landscape. So it's a very good opportunity for us to go out there as economists and try to collect the data that is specifically designed for our research purposes. Thank you very much.
Alberto, thank you. Alberto, thank you for this insightful presentation. Now we move to the second speaker of the session, Stefan Bender, the head of Research Data and Service Center of the Bundesbank. Before joining the Bundesbank, Bender was the head of the Research Data Center of the Federal Employment Agency here in Germany. And he involved various data-related jobs, not German-related institution, but other institution. He involved with the EU project on data without boundaries sort of things. Without further ado, let me ask Stefan to present his paper.
So,
thank you.
Thank you. As you might see, we are facing two challenges now. First, I try to get the two topics into one presentation. We'll see if I fail, but it will be a nice failure after that. And the other thing is I was presenting before and after Julia, but never sandwiched by her. So before and after, we'll see what's happening there. Just try to summarize what we heard before. We have a large macrofish who is moving in one direction, but we want to have a closer look inside of the fish, and then some guys are swimming in other direction or even are eating from each other. So that's the view we want to have, and I hope that was the summary of the first session with that fishes. So, and what I want to present now is how the Bundesbank are going into giving data to the research community, internal and external, and then thinking a little bit how big data, which also the two speakers before has done it really perfectly, how we can, as a national central bank, we can go into something like that. So, as we have heard already, the Bundesbank is producing a lot of data sets, and normally these data sets or this information in these data sets are aggregated, and then research is done or policy advices. Now, with this kind of much data and you want to go into micro, there's not so much person and time there that you can do all of these research which can be done with these kind of data. There are also limitations about IT resources and, of course, legal restrictions, which are much harder in Germany than in maybe other countries. But although we have these restrictions, or because we have these restrictions, the Bundesbank has launched a large-scale initiative to make a better usage of these kind of data, so for internal and external researchers. So this project is called eMedias, Integrated Microdatabase Information and Analysis System. So that means a lot of these data we try now to integrate, and a lot of my colleagues are on that, to integrate them and to make them available. So the goals are to encourage cooperation between internal and external researchers, and to promote and support policymakers, and even how the bank are reacting or acting to reality. So key principles, what we want to have is data is a public good, so that by definition, these data are done by a public authority, and so they're not privacy owned, so that's a public good, and we want to have democratic access to these kind of data. So normally some researchers already had got these kind of data before, but not all of them. And so to have a broader view to this kind of data, we want to have a democratic access, and of course we have to fulfill data protection issues there too. What kind of data we have? So we have banks, companies, securities, and households. So that's the main issues. The colors do not have to have a meaning on that, so we can change blue and red if you like. On the bank side, we have a lot of information, and I won't read them now not out, that there are balance sheets, financial reporting we have on that side. But what you can see is that we can combine these kind of data of banks. We have the same for the companies, and the nice thing is we can even combine the foreign investments of a company with their relations to banks, so that you can combine these companies with the banks, and we can also combine them with the securities. That we can do because we are using some techniques of big data. That's the second part of the presentation, because we do not have always common identifiers in there, and we have to do that by name and addresses. There are other countries where there is. And already mentioned in the first speak was that we also have household information. That's the panel on household on finance, which is not connectable to the other data sets because of a missing informed consent. Good. This is the data set. And now coming to how do we give access to these data. And so we have on the one side a data producer, which is the Deutsche Bundesbank here. And we have mostly official statistics or administrative data. But in other RDCs, there can be surveys or also even big data. Julia mentioned that NYU is doing something like that. And on the other side, we have internal or external data users. And we are mediating between these two, and we try to control for compliance with data protection regulations on that. How do we do that? First of all, the task of an RDC is, as we already heard, from data creation until data access. And so we are generating in this RDC for non-commercial research. We give the data away, and we're generating these microdata, and we are also linking these microdata, as you have seen before. We're providing this data access, and we're doing a lot of additional work on that. We are doing advise the researchers to a data set. We have to do metadata for the data, which means collecting information. Normally, you need information about the regulation behind that data sets and how that you can interpret the data in the right sense. So that means we need a lot to be done on documentation and methodology aspects on these kind of data. We have started in 2014 to that as a part of the statistics department in the Bundesbank. We already have over 150 projects where external researchers are working with these data. These are 150 active projects for external researchers, and we have a lot of internal projects too. 12 employees are working on that to bring the data in and also to support these projects. And we offering working places for guest researchers where these researchers can work on. So to fulfill privacy and data security issues. So this is a working place for guest researchers. You can see that there are nice rooms. In the US, you normally have to go into a bunker where there's no windows when you look at these kind of data. Here you are on the 20th floor. And normally then data protector will say, oh, you will come with a helicopter and you can see through the window that there is something to screen. No, that's not happening here, so you have a nice view from the Trianon Tower, which is 2 metro stations away from here. Good. I made jokes about privacy, but privacy is a big issue, and here are some examples of that. It was a survey over 26,000 inhabitants in Europe, was collected in end of 2010, and you can see that what the inhabitants of Europe think is personal information is on top financial information. That means financial is top, then medical information are coming. I thought it is the other way around. And then national identity numbers, identity cards, or passport numbers are coming. So that means if you're offering something like these data to the public, to researchers, you have to think that personal information, what we are offering, is top in the perception of people. On the other side, we have trust, and here you see we are only on the third. Yeah? So that means banks and financial institutes, only 62% of the Europeans trust us. So health is much better with 78%, and national public authorities too. I do not need to say that internet companies just have 22, so that's fine with Facebook. So I was astonished that they have still 22. But you have seen we have high sensitive data on the one side, but less trust on that. And to do that a little bit more, you can even say that see that there's a correlation. It's not causality. It's a correlation between trust on the one side and trust in national public authorities on the other side. You see a clear correlation with top Denmark, so over 90% in both of the dimension, and you can see Germany really down the road. So that means only 70% trust in national public authorities, and even below 60% trust in banks and financial institutions. So giving that set up, the question is, should we go into big data? Yeah? And we have seen from Alberto a fantastic presentation on that, and from Julia that we should go into that. And so, as Julia pointed out, the use of big data for research and policy advice will increase. And so we also have to face with the challenge that we will get information from these other sources, and we will face by the results, and we have also to react to that. That's also something we should think of. And Alberto, really fantastic, pointed out how additional data sources can be used to give additional information to us. But I will point out some other additional arguments that we also should think of why we go into big data. That's the nature of found data, the data generating process. We have a paradigm shift in research, and again, access to these kind of data. So you know the definition of big data, so I will skip that and just give you the attention to the fourth V here. That's data in doubt. So that means we have some uncertainty about the quality of these big data. And I was also astonished because, as you have heard, I worked a lot with administrative data in the Federal Employment Agency, and we have worked a lot with administrative there. And if you come in a presentation and say, I have administrative data, everyone says, wow, these data are fantastic, blah, blah, blah. And not thinking about that there's also a data generating process behind that, which is also maybe a quality issue of these kind of data. Are they really in that way they should be? And so that's one of the points. what you will see in some minutes, I do not have a little bit time, so in some minutes, that this quality issue, we should also think a little bit more on that. So characteristic on big data, same as administrative data, they are secondary data, so they are done somewhere for non-research purposes and are reused or transformed into research. Yeah? So that's a little bit different on that. As Julia pointed out, to establish a survey where you ask the people about expectation. We have heard that in the first presentation in session 1. And then you have a clear picture and a clear process about how these data were generated. Yeah? So the amount of control for a researcher varies between different types of big data sources and even between the sources. Now the thing is not working anymore. Ah, yeah, now good, thank you. So if you think of having made data or found data as two opposites, or design data or organic data, you have surveys on the one side because there's a nearly total control about the whole data generating process, and there's even the idea or a lot of research in the last century, the last years, about how we can measure in a survey, from how to do questions on that to get the right answers or related answers, until to do the right inference about that. And then we have administrative data the last years, which are a little bit more in the direction to found our organic data. And we have even now big data, which is going a little bit more into out of our control. Good. But big data, as Julia also pointed out, is not only data. It's also a more or less precise or imprecise description of a rich and complicated set of different characteristics, practices, techniques, ethical issues, and outcomes, all associated with data. So we already heard Alberto talk about machine learning, which is a technique which is now coming from computational science also to us to transform data or to bring data together. Ethical issues were raised about, is informed consent still working on that? And so there's a lot of these discussions going on. Coming now, as I promised, to the data generating process, and then I'm nearly at the end of the presentation. As I said before, big data is often selective, incomplete, and sometimes full of errors on that. So, and normally, if you work with big data, you have to aggregate them, take them from different sources together, and integrate them into one data set. And because of that, it's really challenging to do that. And this is normally done putting these data sets together, extract, transform, and load them, and then analyze them in a second step. So, but for this process, and it's really related how we treat our data now in a central bank on the micro level, we also put these data together, transform them, and link them. Yeah? So it's now nice that with this big data discussion also now survey methodologists are interested in how we can define a quality measure, or to see how these total error on working with these data can be calculated and measured. So, and because of that, as I said, we do not have that for administrative data at the moment. It's nice now that with this discussion we are in there. So summing up is that hopefully we all agree that policy advice and research is about answering questions, and Christoph Schmidt has pointed that really clear out, that we also have a strong need for granular data and that we need an access to this kind of data. And as I said, how these data are transformed, and we have to work on that. It must be in a secure environment, and we think that what we have established here, this research data and service center, is a place where we can let researchers work on that with fulfilling privacy. And new possibilities, as we have seen in the two presentations before, is that we can combine these different data sources, our big data, service, administrative data, to have best of 3 worlds on that. And because we know the quality of service and which we can do and not can do on that, we can bring the other data in and to see that we have a better data quality at the end by combining these data too. And as I hopefully pointed out, and I guess Julia will do that now, is that big data is not only data, which normally is popping up in the discussion, it's about a new thinking with data. And I will end now with that we also should think about who has the information and who we should give away this information, because on the one hand, and I like this citation from Christie, that's why I end with that, is that on the one side we can increase welfare, lower search costs, and reduce economic inefficiencies if we have this data and the access to this data. But on the other side, it can be loss, it can work, or it can lead to economic inequalities, because we have to distinguish who has this data and who has not this data. And I think that this is one of the arguments why we should do something like a research data and service center to put out these data, to give this transparency back to the public, and to also serve and increase this welfare with this kind of data we have. Thank you. I hope it wasn't time.
Thank you, Stefan, for this comprehensive presentation on the big work you're doing on big data here at the Bundesbank in Germany. Now we are going to change the order of our discussant, and Professor Lane is going to take a flight, so he has to leave early. So she doesn't require any introduction, let alone a second introduction. So floor is yours.
Thanks. I actually have to, I apologize. I got in this morning. I have to go back and teach. I teach a big data and social science class for federal statistical agencies, and it's every Friday. So I fly back tonight and teach tomorrow. So again, the key ideas. So I've argued before that we've got a new scale of social science. I really think that what we need to be thinking about is major research infrastructures, and that's going to take community engagement, okay? So here's what we heard, and these were 2 terrific presentations, so thank you very much, guys. On the one hand, we heard about the potential to use massive amounts of information from a wide variety of sources to get at new measures of price indices. And then you heard a very thoughtful discussion of what the issues were that were associated with measuring those prices, what was being contained, what was not being contained, and so on. So this is where, you know, the combination of computer scientists and economists and social scientists, statistical agencies, it's just a beautiful thing to watch that happening. How people can go in and replicate that analysis, extend it, you know, build a community around those kinds of data. It's almost impossible. I haven't talked to Alberto about this, but I imagine it's almost impossible for him to share that data easily. So one vehicle, and I would argue that a major vehicle, is the type of RDC that Stefan has described. So what I want to talk a little bit about here is what are the implications of this? I talked with Claudia a little bit beforehand about what would she like to have come out of this workshop. So what kind of things should you be thinking about as a community to build an infrastructure around this? So, you know, one way to think about this is to think about a data hub or a data RDC 2.0. So I live in New York City now, and you know, there was this big thing about 3 or 4 years ago where all the cities were going to make their data open. And the White House led this in 2009, Anish Chopra, Beth Novik, and so on. And so lots of data was put out. So I think by and large, what happened was you got things like this. So New York City is one of the lead cities with making the data available. University of Chicago, Chicago is another one, but it's a big push. The take-up on that, take-up on simply making data available, I think the correct term is mixed, right? I think that's the technical term. So essentially what happened is the data go out and it's a vomit of data, right? It's just this massive, this laundry list of 3,000 data sets, and it's down there like that. Now contrast that with Amazon, right? So I actually went on, I have an Amazon account. I hasten to add, these are not just my preferences, my kids have access to this as well. So the violent movies is my son, I think. I didn't know about that beforehand. But you go into Amazon, and it's not this. It is people like you have used stuff around this area. So imagine going into an RDC, and instead of having a laundry list of data files, it is, well, you know, I've looked at your description of your research proposal. I've done some text analysis on it, right? And guess what? There are other people who are interested in the real exchange rate, and they used a data set like this. And here's the code that they used, and here's the variables that they used. So instead of, think about a 21st century research data infrastructure that actually use the types of approaches that we see in other parts of the community. The technology's there, it ain't that hard. Well, I mean, Amazon's making a lot of money out of it. We don't have to make a lot of money out of it, but we can learn from each other. And so, you know, you can build a community around that. So what do I mean by a community? So I'm trying to make these anonymized slides because I went to another workshop with an agency that I would like to remain anonymous. I tried to cut off the logo, but it didn't quite succeed. And they were, they were developing taxonomies. So one of the things that I learned with doing data is, again, you always want to avoid dragons. There be dragons. There's always some librarian trying to create taxonomies and making you want to adopt them and saying this kind of stuff. And so they're developing classifications that if only they could get researchers to fill out the classification and get the codes right, they could just pull everything up beautifully. Well, guess what? People don't actually do that, right? Just very quickly, when I was at NSF, we had to code proposals into basic or applied, the proportion of a research proposal that was basic or applied. So, of course, everything we'd code 80% basic, 20% applied. Oh, yeah, that's what we did. Every program officer, every proposal. And then the edict came down. You had to code everything 100% basic because NSF only did 100% basic research. So magically overnight, all research at NSF became basic research. So, you know, forcing people to fill out taxonomies isn't a particularly appropriate way of doing it. So, and to create metadata. That's essentially creating metadata around the documentation. So how do they do it in the rest of the world? Well, here's the Western here in Frankfurt. Now look at that metadata. People provide metadata about the things that you want to know about the Western because you create incentives. You give them stars, you give them badges, and you know, people, you know, you get little feedback things. So imagine creating incentives so that if you create particularly useful metadata about a data set or code that people use, that metadata generates out of the research community itself. And you can generate it actually just from the language that people use to describe their projects. So this is work that James Evans has done at the University of Chicago. This is in the scientific context, but you could imagine using it in a variety of different contexts. So, you know, any project, I've been in this R&D and innovation space for a bit, so any research project has metadata built into it. Any description has metadata built into it. The opening line usually says what you're going to do. Then it says how you're going to do it, and then it says the methods that you're going to use. So you can pull that out using computational linguistics and develop facets. Not because you're forcing anyone to fill out a tag, but it gets generated out of the language that they create. And then that is the kind of thing that you could use to create useful metadata and documentation. So that's the kind of thing that we're trying to do in conjunction with Stefan, obviously, create an RDC 2.0 instead of a dark bunker with a laundry list of files and non-replicable research that's buried in some kind of do folder and analytical folder, but develop an RDC 2.0 in which the community can work together to provide this. It's been done in other fields. The Large Hadron Collider, you take a look at many of the papers that come out, there are several hundred co-authors. And if you take a look at much of the work that's been done in other fields, communities do build around it. The Sloan Digital Sky Survey is an example. So there are many other fields in other scientific areas. And this is, if I had to suggest a way of moving to get this granular data to be something that's of use, it needs to be a community effort and provide the kind of modern tools and technologies that help you do that. So that's my key ideas as a result of their comments. So thank you very much indeed.
Well, thank you very much, Professor Lane, for this another insightful presentation on big data. Our last panelist, Patrick McGuire from the BIS, is going to discuss Alberto's paper. He's the head of International Data Hub at the BIS. Patrick, the floor is yours.
Okay. So thank you very much for the invitation today. As I mentioned, my name is Pat McGuire. I'm the head of the International Data Hub in Basel. I'm going to have a very brief discussion of Professor Cavallo's presentation, in the sense that I am not by any stretch an expert in big data, but I have done some work in cross-border banking and thinking about exposures, and so this invitation to this conference today had to force me to think a little bit about the concepts of big data and how they apply to some of the questions that central bankers are interested in when it comes to cross-country exposures. And that will lead me then into a discussion of what's currently underway, the work that's underway in the BIS International Data Hub, which came out of the FSB IMF G20 Data Gaps Initiative. So on the Billion Prices project, I thought it was a fascinating initiative. To me, it seems like a perfect application of new technology to aid in macro monitoring across countries. It provides more timely and accurate measures of inflation than traditional CPI data. I thought the case of Argentina was particularly fascinating, and I wonder how many other countries are like that. I think I read on the web that the Economist magazine had changed its switched in its publication to your measure rather than the official measure, which I thought was quite interesting. And it was a nice discussion of the limitations as well, some of which, as you note, seem not always to be particularly relevant. At the bottom of the slide, I put some questions on there. This is more of just sort of kicking the tires rather than any kind of critiques of the presentation. Most of these were just getting, I was interested in a little bit more information on what types of products, the span of products, how far out of the retail space do you actually move with this, but perhaps we can take these up at a later time. when thinking about this project, though, I was interested in finding out, well, the BIS is an institution that serves central banks, and we tend to think about questions that central banks are interested in. So I started thinking about, well, what is out there on big data that can help central banks do what they need to do in their global macroprudential, microprudential monitoring. And when I go on Google and I start thinking about big data, probably the first 200 hits are items relating to how businesses can use big data within their own organization. Then you move a little bit beyond that, and there are things on macroeconomic variables and market sentiment, consumer behavior, purchasing patterns, unemployment, things that I tend to think of as a price type of measure. What I was less convinced of, or what I saw less evidence of, is where is the big data going to help us really figure out global, particularly cross-country balance sheet linkages. And here I have in mind actual exposures. So at the bottom of the slide here, I have sort of 3 questions that certainly came up at the BIS, I know came up in many of the central banks around the world during the crisis and afterward. European banks' global exposures to US real estate. Now that is not a particularly easy question to answer using IMF or national data, flow of funds, these sorts of statistics. And it turns out that it wasn't a particularly easy question for the banks themselves to answer, even at the individual basis. This concept of exposure is a pretty tricky thing. Are you talking gross versus net exposures? What do we think about in terms of netting sets, multilateral netting agreements, collateral practices, imperfect hedges? We may shove all these kinds of position information into trade repositories and in CCPs, but you add all that stuff up in a linear way, even if you had it all, and there's no guarantee you're going to get any real measure of what an actual exposure is. Consolidated balance sheets, in a multinational world, tend to transcend national borders. So national data, without some sort of a nationality breakdown, is really no longer enough. And what's really lacking is information about corporate hierarchy, both on the reporter's side as well as on the counterparty side. When inside a firm, this information becomes very highly confidential very quickly, and it's not particularly on the web. And while some of this data does exist at the national level, it's typically not shared even within a particular country across agencies, and almost definitely not shared across borders, allowing you to create a national view, or I'm sorry, a cross-country international view. And so what we've created at the BIS was this sort of micro hub, the BIS International Data Hub. And as I mentioned, it came out of this FSB IMF Data Gaps initiative. There was 20 recommendations in that originally, but there were 2 in particular that called for more information about GSIBs, or globally systemically important banks' bilateral exposures, and their broader exposures to countries and sectors. The data hub is basically, there's 11 participating countries where the GSIBs are headquartered. It's governed by a hub governance group. These 11 countries have signed a multilateral framework agreement, which is the rules, if you will, for governing how data is shared. And then the hub went live in 2013. We store highly confidential weekly balance sheet data. I'll talk about that on the next slide. We assess the data quality working with supervisors. We then basically use this to produce analytical reports, which we spend weeks and weeks writing, and then we dump them into a hole in the basement so nobody in the world can ever see them. Not seriously. We provide these to supervisors, but that's about the extent right now to which they're shared. And then the Data Hub serves as the secretariat for the Hub Governance Group. So the nuts and bolts of what we collect are these data sets that are listed on this slide here. I to I stands for the institution to institution, which means basically bilateral exposure data on a top for the GSIBs and their top 50 counterparties. This is going to be expanded in 2016. And a moment ago, I mentioned that the banks themselves weren't able to collect this. And this is where my questions about how this type of exposure data, how big data will ultimately help us. The story that I had heard several times for the genesis of this data and the senior supervisors group that originally collected it in the New York Fed was that, you know, around the time of the Lehman collapse and other large banking collapses during the crisis, the supervisors sat down the CEOs of all the big global banks and said, we have to make a political decision. Are we going to bail out such and such bank on Monday morning or not? We need to know what your exposures are to this particular institution. And it turns out that not a single bank could tell them, because each of these giant banks is 2,000 or more subsidiaries around the world, and Lehman and the other banks that failed, Bear Stearns or whatever, themselves were over 1,000 different legal entities around the world. And so with the mergers and acquisitions that had taken place throughout the 90s and early 2000s in the banking industry, the risk management systems were simply not in place to be able to allow any one bank to consolidate its global exposures to any other one large institution. So it's not clear to me if this is the state of the multinational firms around the world, where the big data concepts that we talk about are going to help here. For me, I see that there has got to be a coordinated international effort to force firms to get their own risk management systems in such a way that they can produce these data for themselves. The original impetus for this amongst the supervisors was not so that they had the data. It was that they were so shocked that the firms themselves couldn't produce the data for their own use. Well, now we're there with the banks. The banks have been producing this, the big banks anyway, have been producing this for a couple of years. The question is what happens for large asset managers, insurance companies, and other things, which I'm sure others will talk about later in other sessions on what's happening with the second Data Gaps initiative. So that's sort of where we are with the institution-to-institution data. We have two sets of that. On the credit side for exposures and on the funding side, so you can see each firm's top funding providers. Then we have what's called I-to-A data, which is institution to aggregate data. So think of that as Deutsche Bank's exposures to the non-bank private sector in China, broken down by various instruments and currencies and other things. There's no bilateral, there's no single counterparty on the other end, but rather a country and a sector. And this data will then get more granular in phase 3, which was just recently approved by the FSB plenary, I think in September, and the reporting of this will start in 2017. In terms of the sharing arrangements, right now the data is fairly closely held. We produce reports that are currently going to supervisors and central banks in the 11 participating jurisdictions. With phase 2, originally it was just with supervisory agencies. With phase 2, it went to some of the non-supervisory central banks that are contributing data. And then with phase 3, the international financial institutions, which it basically constitutes the BIS, the IMF, and the FSB, will have some limited access. And the goal here is to aid in macroprudential surveillance and regulatory design. So you can think of initiatives where the Basel Committee or an FSB working group says, oh, we're going to go out and do a brand new large survey data collection and ask all the banks to do X, Y, and Z. Well, if that can be avoided by using data that's already collected in the hub, the idea is that we should make that possible so that we're not further burdening the banks. So even though I said a second ago, the international community has to sort of force the multinational firms to be able to produce these exposure metrics, I'm absolutely conscious of the reporting burden that this places on firms. So it's important that international institutions and regulatory authorities do what they can to minimize the reporting burden on industries that are already sapped with brand new reporting requirements after the crisis. So some of the operational challenges that we faced in the hub, this is my last slide, so, that we faced in the hub was, basically ensuring common reporting bases. And this is where, you have all these big data sets that float around in different countries at a very micro level, loan level data sets or whatever. It's not clear to me that for the big multinational firms, these data are going to be internationally comparable without some standard guidance to bring them into some kind of a common framework that they can be aggregated meaningfully. And then the other thing is the identifiers for the corporate hierarchies. we spend a huge amount of time sorting the names of counterparties that arise. Should it be an exposure to PIMCO or Alliance, which owns PIMCO? There is no LEI yet, or I guess the LEI is there, but it's in its very, very early stages. If and when this thing really takes off, that will be a huge benefit for all of these sort of data collections for cross-country exposures. But unfortunately, it doesn't seem as though it's in wide use quite yet. And then access and sharing. The data that's in this hub is highly confidential. It's locked down pretty tightly. And in many cases, the countries simply don't have the legal gateways. This is not a question of do we like the guy or not that we were asked to share with. It's that the supervisory authorities simply do not have the legal gateways because of national law that allows them to share the data outside of the supervisory community. And so even if this data is collected, for making wider use of this by macro-prudential authorities, international countries need to work together on establishing legal gateways to make this happen. And then finally, I've noticed, at least in the reports that we produced, the supervisors themselves had to adjust to change their own scope of monitoring now that they were for the first time receiving information about the exposures and the linkages with all these other banks from all these other jurisdictions that they previously had not had any information about. So just in concluding thoughts, big data should be exploited wherever possible. I very much like the Billion Prices project. But the key financial stability questions that require linkage data, I think, need some international coordination to make sure that the definitions of what is collected yield data that can be meaningfully aggregated. And this will take time. And that, thank you.
Patrick, thank you for the expert discussion of the first paper and your expert information on the activities of the BIS International Data Hub. Well, that concludes the presentation of panelists. Now, floor is open for your questions. Any questions? Catherine.
I have a question to Alberto. I'm very, very curious about what is behind your figures, the figures that you produce about inflation. So my first question is that if you have any control for the basket, what kind of data do you get if you have a basket that you combine the figures, the prices after? And then because if you will compare your data with other indexes that are produced for some countries, they should have more or less the same basket. And if you get the data from the consumers or if you get the data from the retailers, because if you get the data from the consumers, you can have a consumer bias because not everybody accesses computers. And if you get it from the retailers, then you get some bias from the suppliers because you don't get groceries and other things. And how you measure this. And also because if you get the data from the stores, then you have this kind of algorithm that the Professor Lane has shown that in your case is not so positive because it will introduce always a bias in my choice when I will buy something, and then this will be inside your index. So thank you very much.
That's a very good point. That's why we like going and designing our own data collection, visiting the website and deciding what is it that we want to collect instead of asking the retailers to give us the data. Because you're absolutely right. First, if you ask a retailer, for example, scanner data has that problem, you have to ask them to submit their internal information, they have to devote resources to it, they have to do it periodically. It's very hard to get their cooperation, and then you're always not sure exactly whether there are any sample selections there in the data you obtain. We do it very differently. We decide firsthand what is it we want to collect, and then we go out ourselves by putting very little burden on the servers or the retailers. They barely notice this. And we make sure it doesn't impact them negatively in any way. But we place a lot of emphasis on designing our data collection. And that's what I was saying. I view this big data, in terms of economic indicators, I see it more as a data collection tool that has become available to us. We still have to design it, how we want to run that data collection. What Julia, for example, was explaining she's doing, you can think of all these records being created for other purposes, but they're designing the way they want, choosing what is it that they want to collect, and that remains the same principle that statistical agencies have been using for a very, very long time. It's just that what I'm saying is instead of often, for certain goods and categories, no, instead of walking physically to the store of a large retailer, you can now use the web to get to that price very quickly, very cheaply, and that liberates resources to do data collection better in other sectors. But that's absolutely correct. And in terms of the baskets and methodologies, we try to use as much as possible the same baskets and same methodologies used by statistical agencies, and that's why we can make that comparison. You're absolutely right. We're not relying on indicators we build ourselves in terms of expenditures, simply because that's information that we do not observe. Having said that, for example, scanner data could potentially be very good to improve the way we run consumption or expenditure surveys, no? Which are traditionally done on a periodic basis. Maybe scanner data can inform, in supermarkets in particular, statistical agencies better what is the basket that consumers are actually purchasing. But it's not something we can do with online data, potentially maybe done with scanner data, and that may be down the road as well.
All right.
Just two short questions. One to Stefan. You had this graph on the trust in the protection of confidentiality, and you showed that the public authorities have a much higher rate than banks and financials. But why did you put the Bundesbank and central banks to banks and not to public authorities?
Point, yeah.
The second question, very briefly, to Patrick now, as you mentioned at the end, that the problems of sharing data. Now, how do you see the new data gaps initiatives, 20th recommendation, which actually says that data sharing between authorities should be encouraged and even potentially confidentiality rules should be revisited? You think this is going to make a difference? Thank you.
Should I first? Sorry about that. But I think the argument is the same because it was a clear line between the two scales. So the regression line was the same. So I think the position would be the same for Germany if you do the both. Yeah, you're totally right. Yeah, definitely, yeah.
I'm not sure, is this on? On the question of moving forward with the sharing, so I think the HGG is cognizant of the fact that macroprudential authorities need better data to make policy decisions, and I think what's happening with the implementation of the phase 3 of the first data gaps initiative is say a middle ground, if you will, whereby the data will stay in the secure environment, but the ability to draw on the underlying data for broader questions will start to happen via ad hoc requests to the hub, via teams of supervisors or teams of people from various of the say BIS working groups coming in to draw on that data for larger questions. I'm personally not in really a position to comment on whether national authorities are in a position to start changing their laws at home about sharing of information. So this is I guess I can say is a work in progress.
Thank you. Any more questions? Somebody at the back?
Thank you. Yes. My name is Lydia Bratanova, and I'm the Director of Statistical Division of the United Nations Economic Commission for Europe, UNEC, based in Geneva. And one of the topics that really interested me here was the discussion on big data. And so I followed with great interest both presentations, and I'm happy with what the conclusions were, more or less. And I'll tell you why. We work with the heads of statistical offices of all our member countries, the national statistical agencies, These are 56 countries plus OECD countries. And the work has been led by a so-called high-level group. Maybe some of you have heard high-level group on modernization. And about 32 statisticians 4 years ago asked the question, what is the importance of big data for official statistics? And the very first concept note was written. In the last 2 years, we have had a number of projects experimenting the role and the value of big data for official statisticians. And this was done, as here also was mentioned, in a collaborative way, sharing experience with a big computing center in Ireland where different research official statisticians could have access and experiment. And the conclusion that we are reaching, or experts, it's not me, it's the country experts, is that there is a growing skepticism about how much big data can be used and to replace official statistics. And we are over the hype of the importance of big data because our research shows that big data cannot replace official statistical production, nor can produce new outputs. Now, the conclusion, which also in my view came through the two presentations, is that big data can be used as a supplementary source and can validate existing sources. But what I also very much in line with the conclusion of the colleague from Bundesbank is that the attention is turning towards combining data sources, or as we call it, integrating data sources. And that's the future, combining data from surveys, administrative data, and also some big data. So here is an outcome of nearly 2 years of work among the official statisticians, and it's a bit in line with the conclusions I heard from my colleague from Bundesbank. Thank you.
Thank you.
Thank you very much. Silke Stapel-Weber, Director for Macroeconomic Statistics at Eurostat. I also followed the discussion with great interest, and unfortunately Professor Lane has already left because she said one sentence I cannot refrain from commenting on, and that was that the role of national statistical institutes will decline. I was surprised that Lydia didn't say anything about that. I would like to ask the question, actually. So far we discussed a little bit what can big data do, what can big data also do for official statistics, for instance, for research. I would put the question the opposite around. What can official statistics do for big data? And I think there is a role to be played, and I would not agree that the role is declining. It's just a different role. And where I see the role is exactly also in line with the last discussion. I see it in and I would include in statistical institutions also the international statistical institutions. Yeah, it's in working on comparability and harmonization, definitions, classifications. Yeah, I see the role of statistical offices also as a kind of a benchmark, of a frame, and that combined with multi-source approach. None of the traditional and new sources will solve the problem alone. I would be interested in the opinion of the panelists on this notion, what official statistics could do for big data. Thank you.
Thank you.
Maybe, if I may tackle that, I agree completely with you. I think if you think about what statistical agencies can do, they have the expertise of how to build some of these statistics. On one hand, I described how it's now becoming easier for other people to collect their own data, but many of the firms that are collecting data for other purposes don't have the statistical expertise or even the incentive to actually generate an indicator. Now, from the perspective of statistical agencies, and I work with many of them, I'm in the advisory committee of the BLS, of the ONS, I try to show them that if they're open to these new techniques and see them not as a supplement, but rather as a complement to what they're doing in a potential way of improving some data sources in some sectors, the role may not decline, but rather be redefined, and essentially at the core of it, it will be the same, because it's that knowledge on how to produce statistics that makes us trust official statistics more than private statistics as any other institution may be able to collect. The trust, any statistic, if we're going to use it, we need that trust, and official statistics have that stamp of approval in most cases. Obviously, the case of Argentina right now wouldn't be that situation, but in most cases, that is the situation. And I think that's the opportunity, and you should embrace it instead of feeling threatened by it.
I promised to answer all of Julia's questions, so that I have to do that. First of all, I think two arguments were, if you think back to the 60s, so there was a monopoly by the official statistics. There were not so much other information around, and official statistic was those who gave information or data. So now the world has completely changed, and I even have seen a presentation where someone said, if you think this room is the data we are producing in this minute or in this second, then this pen is what official statistics is doing. So the rest is other data. And we can now discuss a little bit about, is this kind of data really in the quality or in the issue that it is to official statistics. So, and the other point she made is what kind of publication with research are we facing with? And there was first all went into surveys, then a lot went into administrative data, and now they are going out there. So, but we can discuss about if research has also something to do with fashion. So I'm not really sure if I think she will agree to that too. So I'm totally agreeing to your point that we have to, that official statistics have to find a different role on that, because and I do not think that a lot of official statistics, as far as I know, are reacting in a good way, that they are now doing a closed job too and not opening to these kind of movements or these new data sources. And I was really happy to hear what other banks are doing or what you have done. And I think there is an improvement in blending these kind of data and to see about what are the qualities of the different sources, and you have done it in a perfect way, I guess. Yeah.
Okay, thank you. Well, our time is up. So I'd like to thank our 4 speakers for the 4 great presentation. Thank you very much.